Welcome dear students. Today we shall discuss application of integrals. Here we are going to discuss the questions of exercise 8.1. Our topic is area under simple curves for the students of class 12 subject mathematics. So first of all, according to the topic area under simple curves. So we have, this is the bifurcation. We shall study this in two ways. First way is, suppose y is equal to f of x. This is any function which is defined in x belongs to a to b. This is the interval in which the given function is defined, well defined. So here, suppose we have the Cartesian plane, x-axis, y-axis. This is the origin. So here the curve, this is the curve, and the initial point of the curve, from initial point of the curve we draw perpendicular on x-axis. From the origin, suppose this foot of perpendicular is at a distance. Similarly, from the terminal point of the given function f of x, again draw one perpendicular on x-axis. Again, suppose from origin to this foot of perpendicular of the terminal point, terminal perpendicular, suppose this distance is b. So this function f of x is well defined in x belonging to a to b closed interval. Now the question is how to find the area under this curve. This is the way. Area I am going to shade here. Which area we are going to find, we are going to calculate. So this is the area which is shaded here under the curve up to x-axis. We shall discuss the area under the curve up to x-axis only. Okay, how to calculate this? The formula is required area under the curve is equal to limit x is equal to a to x is equal to b f of x dx. This is the way. If we substitute here, we can find the area which is closed, which is enclosed under the curve f of x. Similarly, if the function is like this, x is equal to f of y, where y belongs to c to d. Y, the function f of y is well defined in closed interval c to d. Here what we do, again we have the Cartesian plane, x-axis, y-axis. This is origin O. But here the curve is like this. Okay. Here the initial point is this and terminal point of the curve is this. Name of the curve is f of y. Again what we do, from the initial point we draw perpendicular on y-axis, and suppose from origin to this point the distance is c unit. Similarly, we draw perpendicular from the terminal point of the curve on the y-axis, and suppose from origin this distance is d. Now shading the area under the curve up to y-axis this way. This shaded portion is the area which is enclosed under the given curve f of y up to y-axis. So question is how to find algebraically required area. Required area is equal to limit, here we put y is equal to c to y is equal to d f of y into dy. Okay, so this way we can find the area. These are the two methods we can solve the questions with the topic area under simple curves. Now coming to the questions of the exercise 8.1, the very first question is find the area of the region bounded by the curve y is equal to x square and the lines x is equal to 1, x is equal to 4 and the x-axis in first quadrant. So my dear students, first of all we have to recognize the curves. First of all, what we know? We know that x square is equal to 4ay. This is a parabola. This is the equation of the parabola. Okay, so this equation, given equation is y is equal to x square, that is x square is equal to 4ay. This is of the same form, so this is also a parabola. Which kind of parabola is this? This is called upward parabola. Okay, this is the rough sketch. First of all we are sketching roughly, right? Now second thing is x is equal to 1, x is equal to 4. So somewhere here will be x is equal to 1, somewhere here will be x is equal to 4. So lines will be this and this way, right? We shall draw. Mean to say we are required to find the points of intersection of the lines and the curve parabola. So first of all, how to solve the question, how to start the question. Solution is here. Given curve is xy is equal to x square. Suppose this is the equation number 1. So what we do, put x is equal to 1. This gives y is equal to 1 square. So this gives x is equal to 1, y is equal to 1 is the first point of intersection. Similarly, second time put x is equal to 4. Put x is equal to 4 where in the equation 1. So this becomes y is equal to 4 whole square. So this way we have the second point of intersection. What is that? X is equal to 4. Similarly, here from by putting x is equal to 4, we have y is equal to 16. So these 2 points of intersection we have obtained. So this way now we can sketch the graph. How we can sketch the graph? This is the Cartesian plane, right? In the Cartesian plane, this is x-axis, this is origin and this is y-axis. Moreover, what we can do here, we can say this is the y-axis. Okay, now this way vertex of the parabola is this. We have x is equal to 1, 2, 3, 4. Similarly, we can have here suppose this is 2, 4, 6, 8, 10, 12, 14, 16, right? So this is 1. So first point A is 1, 1. So here we have the point. Second point is x is 4, y is 16. X is 4, y is 16. This is b point 4 comma 16. So this way we have the curve right. Now what is their equation? Equation is x is equal to 1. So x is equal to 1 is the line parallel to y axis. So this way this line is x is equal to 1. Second time x is equal to 4 is the second line. So this way this is the x is equal to 4 second line. Now what is the question? Find the area of the region bounded by the curve y is equal to x square. The name of the curve is parabola is y is equal to x square. So area covered by parabola, line x is equal to 1, line x equal to 4 and x axis in first quadrant. That area is this portion, the portion which is being shaded here, right? So this way we have shaded the area which is required to be obtained, right? So we have shaded the area now up to x axis in the first quadrant. So only under the curve where this point is a point and the coordinates of a point are 1 comma 1, that is x is equal to 1, from starting from x is equal to 1 ending with x is equal to 4. So how to find the area now? Required area is equal to shaded portion between x is equal to a to x is equal to b, f of x into dx, f of x into dx. So f of x mean y is equal to x square in this question. So we have x is equal to a. What is a? A is 1. To b is 4 and f of x is x square into dx. So this way we can solve this. Integration of x square is x power 3 upon 3, 1 to 4. So this way we have 4 raised to power 3 upon 3 minus 1 raised to power 3 upon 3, that is equal to 64 minus 1 upon 3, which is equal to 63 upon 3 square unit. So this is the required area.